Oh dear God.
That was 10 minutes and 6 seconds
60.
of perfection.
16 minutes. It was 16 minutes.
Okay.
Look at all these hands.
Okay, let's do it.
What controls the concentration of the signal?
Concentration of the signal. In this case, it was the presence of the poison alcohol.
That poison.
Correct. It inhibited sonic signal. By the way, sonic is a very real story. I didn't make any of this up. All of it was real. The disease is real. Cyclopamine is real. Alvor is real. Cyclocow is real. Sonic hedgehog is real.
Yeah.
Yeah. So I'm working with that.
You said when we increase concentration, the eye won't even produce. Then how come when we decrease concentration, the 3 level will be lowered down? So when you increase it, should it just be pushed farther back?
Yeah, but what I'm saying, it's not like you get more I at level 4.
Okay.
Right? It's like you needed that specific balance of proteins, A and B exactly, to produce the I there. I think just a more simpler model would have been large I here, small I here, perfect I here. It's not the way it works.
So, if you find this balance more than once, you have more than one equation.
Say it again.
So, if you find this balance more than once, you have more than one equation.
Yes, however, it's going to be not just one signal. So if we actually take this, what we're going to have is more likely it's another set of signals being produced here, and even a set of signals that are being, several sets of signals that are being produced. So each so imagine, like really dense So this particular combination of green and black concentration from many different signals is one of the ways your cells will identify where they are in your body. And responding.
In the diagram you used before, the triangles were the transcription factors combining with the promoter.
Right? Because if we have a signal and no transcription factor, it really has no effect.
Okay, and the concentration of the signal says how many transcription factors were recruited, and that depends on how many genes.
Correct.
What was the last one? That depends on how many.
So the amount of signal determined the number of receptors we're going to bind to. In these cases, the receptors are enzymes. They're going to activate transcription factors. You can see they're already here. So we probably phosphorylated them. So this adds a phosphate group to a small number. These 2 add phosphate groups to larger numbers. These 3 add phosphate groups to very large numbers.
The same amount of like A, B, and C is still being produced, right? Like there's a certain amount of A being produced when that happens. The same amount is being produced when A and B are
Right.
Okay.
Right. It would look like a step function. It would probably look like if this was transcription factor, then it would be like none A. So this would be A. Right. It's kind of cool, man. This is how it all gets coded. It's okay to be sleepy. I don't take sleepy as much. Yeah.
But like, how does that cell know to become sensitive to that signal?
It doesn't. Does this cell know how many receptors it's making? No.
Then how does that cell
This cell is programmed to make these receptors all the time.
But like, your skin cells don't have the same receptors as your eye.
Right. Exactly. So we're going to. This is going to happen in many different instances. At don't forget, at some level, you're those two cells, right? You're dosage. And if I shut down the ability to make a receptor in that bottom cell right away, then only the top half of your body produces a receptor. You can do that at many, many different stages. With me or not? Two cells. Only the top one produces receptors that look like this. This replicates a bunch of times. Now, the top 3 cells produce tick receptors, the bottom 3 don't. Only the middle one produces circle receptors. Because I could have these 2 cells produce a signal that only this would sense at super high concentration. Because it's surrounded by 2 of them.
How do you get to the problem? Something outside.
This is going to be the problem that you're going to run into. This is the beast.
Any external signals?
What?
You have external signals contributing to the internal cell makeup. Create proteins that give off signals.
Sort of.
Isn't this external? It's coming from alcohol.
Yeah, this is external signal. This original difference factor. You guys see the beast? You guys see it happening?
Kind of.
He designed a mechanism that could work, but life doesn't use.
No, you have to. You will be only allowed to use mechanisms of life. However, you will find that life is more creative.
Does life occur, like, for example, like in cells? Does this ever happen in real life where one cell receives a signal and then that cell releases other signals from other cells, called those cells to do something? And those other cells are receptors for that from the cell before, and then those cells.
Yeah, so that cascade event where one cell differentiates another cell, which differentiates another cell. That happens.
I got this.
Okay, hold on. You're not. You're not. Okay, let's go over this again really quickly. Little signal, little receptor activation, little transcription factor activation, A gets activated. You with me? Medium, medium, A, B. I, A, B, C. Let's say C inhibits I formation. A is not enough to make I formation. Only A and B together make I formation. A and B are produced at level 3. Nowhere else.
What does that mean though?
What makes
Level 3 is a level of concentration.
level of concentration? So if I were to measure it here, I would have 5. It could be 5,000, 5 billion. Signal, sure. So it's as if I just divided this up. 5, 4, 3, 2, 1. But that's still 0, 5. What's that? But that's the head. This is the head. Correct. So the concentration gradient, specifically the sonic concentration gradient, you can see here. Nope. Here. So this is the cross section. Sonic's being produced here. Right? This is the higher concentration as we go down. So with this blue level, this level is here. The eyes grow together. In this case specifically, the poison hellebore, will inhibit sonic input. And again, feel free to look this stuff up if you're confused about it.
That cow is just the head.
That is just the head of the cow.
That cow is
I don't see why it would not be edible. What?
If you go like back to the one with like the signal and the concentration, when 3 transcription factors are there, why doesn't it just go to C and not to A? Can that happen?
Okay, so Julia's asking her, yeah. Wait, which one are you? Yeah, you're Julia.
Yeah, that one or the other one, doesn't matter.
Okay. All right, so you're asking,
Like in the second one, why doesn't C happen? Because there's
it could, C could have some,
Okay.
but it wouldn't be enough to activate C.
But if it doesn't activate A and B, it only activates C.
You could not activate this way, you could not only activate C.
Okay.
If I wanted to only activate C, what I would most likely do is have another, this is sensitive to another type of transcription factor, which I would produce, then I would have this in a low concentration here. So I would produce a low amount of that transcription factor and a high amount of it. Yeah.
But does this apply to only your head or is it?
There are examples of this all over your body.
What could like your whole body? Does this apply to your whole body?
So yeah, the original signals are dorsal ventral. They're actually called dorsal and ventral. So they make the back of your body, the back of your body, the ventral part of your front of your body, the front of your body. Any mistake there though, you wouldn't end up with slight confusion.
That is the idea of where lies the whole concentration. I don't know if you know the process laws go down.
So as we go from this low concentration to increase
What's that process?
process,
It's not a process.
this is poisoning.
Avoiding, so like, you're gonna affect the
Yeah, this would be a developmental problem. But, I mean, this is not like a mutation, this is a poison. Alright, this class has got to be over.
Yeah.
It's over.
Why are you still here?